Problem 3, we again graph the functions, see which one's the higher function. We find out that f of x is equal to x over x squared plus 1 is higher than g of x is equal to x minus 1. And we find out the limits of integration are from x equals 0 to x equals 1. Since area is equal to the integral of top function minus the integral of bottom function, we have the area equaling the integral from 0 to 1 of x over x squared plus 1 dx minus another integral from 0 to 1 of x minus 1 dx. Since we can really do nothing algebraically with these two functions that would really help us in the integration, we'll solve the one on the left first. So there's no rule for this, so we let u equal x squared plus 1. du is 2x dx. We don't have a 2 up there, so we'll put a 2 up there and balance it by putting a half on the outside. So we get the integral of 1/2 integral of 2x dx over x squared plus 1, which gives us 1/2. Trading 2x dx for du and x squared plus 1 for u, we get 1/2 integral of du over u, which is 1/2 natural log of u, which is then 1/2 back subbing 1/2 natural log of the absolute value of x squared plus 1 evaluated from 0 to 1. And pausing for a minute, we'll take a look at the second integral, which is minus the integral from 0 to 1 of x minus 1 dx. That becomes distributing the negative x squared over 2 by the power rule. Minus 1 becomes plus 1, and the integral of 1 is x. Again, now we evaluate both of those answers from 0 to 1. So you get 1/2 natural log of 2 minus 1/2 natural log of 1 minus 1/2 plus 1, and then minus 0 when we place 0 into the second integral. We end up with then 1/2 natural log of 2 plus 1/2.